Salinity is the saltiness or dissolved salt content of a body of water. Salinity is an important factor in determining many aspects of the chemistry of natural waters and of biological processes within it, and is a thermodynamic state variable that, along with temperature and pressure, governs physical characteristics like the density and heat capacity of the water. A contour line of constant salinity is called an isohaline, or sometimes isohale. Definitions: salinity in rivers, lakes, and the ocean is conceptually simple, but technically challenging to define and measure precisely. Conceptually, the salinity is the quantity of dissolved salt content of the water. Salts are compounds like sodium chloride, magnesium sulfate, potassium nitrate, and sodium bicarbonate which dissolve into ions. The concentration of dissolved chloride ions is sometimes referred to as Salinity. Operationally, dissolved matter is defined as that which can pass through a very fine filter. Salinity can be expressed in the form of a mass fraction i.e., the mass of the dissolved material in a unit mass of solution. Seawater typically has a mass salinity of around 35 grams per kilogram equals, although lower values are typical near coasts where rivers enter the ocean. Rivers and lakes can have a wide range of salinities, from less than 0.01 grams per kilogram to a few grams per kilogram, although there are many places where higher salinities are found. The Dead Sea has a salinity of more than 200 grams per kilogram, whatever pore size is used in the definition. The resulting salinity value of a given sample of natural water will not vary by more than a few %. Physical oceanographers working in the abyssal ocean, however, are often concerned with precision and intercomparability of measurements by different researchers, at different times, to almost 5 significant digits. A bottled seawater product known as IAPSO standard seawater is used by oceanographers to standardize the measurements with enough precision to meet this requirement. Composition, measurement and definition difficulties arise because natural waters contain a complex mixture of many different elements from different sources in different molecular forms. The chemical properties of some of these forms depend on temperature and pressure. Many of these forms are difficult to measure with high accuracy, and in any case complete chemical analysis is not practical when analyzing multiple samples. Different practical definitions of salinity result from different attempts to account for these problems, to different levels of precision, while still remaining reasonably easy to use. For practical reasons, salinity is usually related to the sum of masses of a subset of these dissolved chemical constituents, rather than to the unknown mass of salts that gave rise to this composition. For many purposes, this sum can be limited to a set of 8 major ions in natural waters, although for seawater at highest precision an additional 7 minor ions are also included. The major ions dominate the inorganic composition of most natural waters. Exceptions include some pit lakes and waters from some hydrothermal springs. The concentrations of dissolved gases like oxygen and nitrogen are not usually included in descriptions of salinity. However, carbon dioxide gas, which when dissolved is partially converted into carbonates and bicarbonates, is often included. Silicon in the form of silicic acid, which usually appears as a neutral molecule in the pH range of most natural waters, may also be included for some purposes. Seawater. The term salinity bullshit for oceanographers, usually associated with one of a set of specific measurement techniques. As the dominant techniques evolve, so do different descriptions of salinity. The distinctions between these different descriptions are important to physical oceanographers but are obscure and confusing According to non-specialists, salinities were largely measured using titration-based techniques before the 1980s. Titration with silver nitrate could be used to determine the concentration of halide ions to give a chlorinity. The chlorinity was then multiplied by a factor to account for all other constituents. The resulting peak-Hanussen salinities are expressed in units of parts per thousand. The use of electrical conductivity measurements to estimate the ionic content of seawater led to the development of the so-called practical salinity scale 1978. Salinities measured using PSS 78 do not have units. The suffix PSU or PSU is sometimes added to PSS 78 measurement values, however this practice is officially discouraged. In 2010 a new standard for the properties of seawater was introduced, the so-called thermodynamic equation of seawater 2010. This standard includes a new scale, the so-called reference composition salinity scale. Absolute salinities on this scale are expressed as a mass fraction in grams per kilogram of solution. Salinities on this scale are determined by combining electrical conductivity measurements with other information that can account for regional changes in the composition of seawater. They can also be determined by making direct density measurements. A sample of seawater from most locations with a chlorinity of 19.37 ppt will have a Hanussen salinity of 35.00 ppt, a PSS 78 practical salinity of about 35.0, and a Teosten absolute salinity of about 35.2 grams per kilogram. The electrical conductivity of this water at a temperature of 15 degrees Celsius is 42.9 millisiemens per centimeter. Lakes and rivers. Limnologists and chemists often define salinity in terms of mass of salt per unit volume, expressed in units of mg per liter or g per liter. It is implied, although often not stated, that this value applies accurately only at some reference temperature. The values presented in this way are typically accurate to of the order of 1%. Limnologists also use electrical conductivity, or reference conductivity, as a proxy for salinity. This measurement may be corrected for temperature effects, and is usually expressed in units of microsiemens per centimeter. A river or lake water with a salinity of around 70 mg/L will typically have a specific conductivity at 25 degrees Celsius of between 80 and 130 microsiemens per centimeter. The actual ratio depends on the ions present. The actual conductivity usually changes by about 2% per degree Celsius, so the measured conductivity at 5 degrees Celsius might only be in the range of 50 to 80 microsiemens per centimeter. Direct density measurements are also used to estimate salinities, particularly in highly saline lakes. Sometimes density at a specific temperature is used as a proxy for salinity. At other times an empirical salinity-density relationship developed for a particular body of water is used to estimate the salinity of samples from a measured density. Systems of classification of water bodies based upon salinity. Marine waters are those of the ocean, another term for which is Euline seas. The salinity of Euline seas is 30 to 35. Brackish seas waters have salinity in the range of 0.5 to 29 and metahaline seas from 36 to 40. These waters are all regarded as thalassic because the salinity is derived from the ocean and defined as homoiohaline if salinity does not vary much over time. The table on the right, modified from POR, follows the Venice system. In contrast to homoiohaline environments are certain poikilohaline environments in which the salinity variation is biologically significant. Poikilohaline water salinities may range anywhere from 0.5 to greater than 300. The important characteristic is that these waters tend to vary in salinity over some biologically meaningful range seasonally or on some other roughly comparable time scale. Put simply, these are bodies of water with quite variable salinity. Highly saline water, from which salts crystallize, is referred to as brine. Environmental considerations. Salinity is an ecological factor of considerable importance, influencing the types of organisms that live in a body of water. As well, salinity influences the kinds of plants that will grow either in a water body or on land fed by water. A plant adapted to saline conditions is called a halophyte. A halophyte which is tolerant to residual sodium carbonate salinity are called glassware, saltware, barilla plants. Organisms that can live in very salty conditions are classified as extremophiles, or halophiles specifically. An organism that can withstand a wide range of salinities is isohaline. Salt is expensive to remove from water, and salt content is an important factor in water use. The degree of salinity in oceans is a driver of the world's ocean circulation, where density changes due to both salinity changes and temperature changes at the surface of the ocean produce changes in buoyancy, which cause the sinking and rising of water masses. Changes in the salinity of the oceans are thought to contribute to global changes in carbon dioxide, as more saline waters are less soluble to carbon dioxide. In addition, during glacial periods, the hydrography is such that a possible cause of reduced circulation is the production of stratified oceans. Hence it is difficult in this case to subduct water through the thermohaline circulation.